Hello future engineers and my dear students, welcome to Mudassar Academy. Today I will be solving the complete VTU model question paper for the 25 scheme, specifically 1BMATS101. This was long awaited, especially since the examinations are very close, and since this is a fresh scheme, many questions are expected from the model question paper just like in the previous years. And listen to me carefully, I also strongly recommend you that you also refer the model question paper of the other branches such as 1BMAT101, 1BMAT101 and 1BMAT101 because many modules are in common. That is, when you study these papers together, they form a very good and excellent question bank for revision for the upcoming exams. I will try to upload a solution to those papers as well as my health permits, and as you are aware of, even though I am going through critical health challenges, I am trying my level best to support you during this crucial time. See, in this video I am focusing only on the questions from the model question paper. Apart from this, please do refer to the playlist and the courses on my channel where I have solved numerous additional problems. Practicing those questions along with this model question paper will greatly improve your confidence and performance in the examination. Also, please don't forget to follow my Facebook and Instagram page for important questions from all modules which forms a very useful question bank for the exams. Now let's begin the solution of the model question paper 1BMATS101. See, I have the printout with me here. The first question is from the module 1, that is A. It says, show that, I write a question here. A, it says, show that ux plus uy equals to u if u is equal to e to the power x plus y whole divided by e raised to x plus e raised to y. Okay. So this is a problem, simple problem from partial differentiation. Okay, so let's solve this now. See, they have given u is equal to e raised to power x plus y whole divided by e raised to x plus e raised to y. So first we need to show ux plus uy is equal to u. So we need to find ux. The meaning of ux is what? Dou u by dou x. That is partial derivative of u with respect to x. Now see here carefully, x is top and bottom, both in numerator and denominator. So which rule? We will follow the quotient rule. So the quotient rule is what? Differentiation of, in a very simple way, derivative of first by second function is denominator second function whole square in the numerator second function as it is into differentiation of first function minus first function as it is into the differentiation of second function. Okay, so I'll do here. So denominator, see second, the denominator whole square e raised to x plus e raised to y the whole square, and in the numerator e raised to x plus e raised to y as it is into derivative of this first function, this first and second. First function e raised to x plus y with respect to x will be e raised to x plus y only. Why? Because differential e raised to x, so e raised to x plus y, e raised to x plus y, again x is 1. Okay, next again minus e raised to x plus y as it is into derivative of second function, the denominator with respect to x, that is e raised to x plus e raised to y will be e raised to x because e raised to y is 0 since we are differentiating only the which terms? The x terms. Okay, so we have it here. So now let's simplify this. So when I simplify, this will be e raised to, see, let's open a bracket, e raised to x into e raised to x plus y. See, according to the law of exponential, e raised to a into e raised to b is what? E raised to a plus b. The powers will add. Okay, so when I add the powers here, x plus x becomes 2x plus y plus, again see, this will be e raised to y into e raised to x plus y. So e raised to x plus y is 2y, and this again e raised to 2x plus y whole divided by, am I right? So e raised to x plus y into e raised to x will be e raised to x plus y plus x, e raised to x plus y whole divided by e raised to x plus e raised to y the whole square. And here, if you see here, see this cancels. What remains? E raised to x plus 2y whole divided by e raised to x plus e raised to y the whole square. Done. Next is we will find for uy. What is uy? Uy is partial derivative with respect to y, and that will be same process. The denominator square, that is e raised to x plus e raised to y square. Okay, now the denominator second term as it is. Now derivative of the first, this numerator with respect to what? Y. So that is e raised to x plus y as it is, because derivative of e raised to x is e raised to x. So e raised to x plus y is e raised to x plus y, again into difference x is 0, y is 1. Okay, minus e raised to x plus y as it is, derivative of the second function with respect to what? Y. So e raised to x, there is no y term, so e raised to x is what? 0. Derivative or differential e raised to y is e raised to y. Okay, done. Now this equals to, so what, tell me? So denominator will be e raised to x plus e raised to y the whole square. Okay, now again multiply. See, e raised to x into e raised to x plus y. The constants, powers x plus y will add, because as I told you again, e raised to a into e raised to b is what? E raised to a plus b. Fine. So x plus x to x. So this will be e raised to 2x plus y into, again this will be, same, e raised to y plus y 2y, e raised to x plus 2y, and minus this c. Here y and y will add, so e raised to x plus y is what? E raised to x plus 2y. Simple basics. Now here this cancels. So what remains? This will be now e raised to 2x plus y whole divided by e raised to x plus e raised to y the whole square. Okay, so as we have got both ux and ui, now let's add to see if the given condition is true. That implies now ux plus uy will be, add both. So we have, see, the LCM is common, so first I write it. Okay, e raised to x plus 2y whole divided by e raised to x plus e raised to y the whole square plus e raised to the power 2x plus y. It's what? 2x plus y whole divided by, again this is e raised to x plus e raised to y the whole square. Now since the denominator is same, we can add both the numerators. This is common, so e raised to x plus e raised to y the whole square, and if we add both, so this is e raised to x plus 2y plus e raised to 2x plus y. Okay, now, so now to prove this is equal to u, what I can do here is that, see, I can, take e raised to x plus 2y plus this is what? E raised to 2x plus y. What I'll do, I'll take e raised to x plus y common. Okay, then what is inside? When e raised to x plus y is common, this will be what? Again e raised to y. Am I right? Because x plus 2y is x plus y into e raised to y is x plus 2y. Plus this will be, see, again here e raised to 2x is there. So I taken e raised to x plus y outside. So what is inside? It will be e raised to x, because x plus y plus x becomes e raised to 2x plus y. That's it. So upon e raised to x plus e raised to y the whole square. See, this term cancels here. You see here, this term and this one term cancels. So what remains? Clearly we have here e raised to x plus y whole divided by e raised to x plus e raised to y. That's all. And that's nothing but what? U, according to question. Therefore that implies we can write ux plus uy equals to what? U. That's it. So very simple solution here. Okay, this is how it is done. Clear? I hope you understood the solution clearly here. Okay, so we are done with the first question from module 1a here. The second one from module 1 is question 1b. If u is equal to x plus 3y square minus z cube, comma v is equal to 4x square yz, w is equal to 2z square minus xy, find dou u v w by dou xyz at 1 minus 1 0. A very important problem from Jacobians. This question they are repeatedly asked in many examinations, and I already solved this problem. Okay, so the solution you will find it in my playlist, and the link is already given in the description below. Okay, so you can check through that. It's a very important question. Now the third question is question 1c. Find the extreme values of the function f xy is equal to xy plus a cube by x plus a cube by y. Again, this is from the topic maxima minima partial differentiation. So this problem also I solved. The link you can find in the description below. Okay. Next, see the next part of the question, that is model 1 is R. Okay. Question 2a. It says if v is equal to f of r comma s comma t and r is equal to x by y, s is equal to y by z and t is equal to z by x, show that x dou v by dou x plus y dou v by dou y plus z dou v by dou z is equal to 0. So similar question I solved. So its question is similar here, only difference is it's directly given u is equal to f of x comma y comma z and z comma x, and show that dou v by dou x plus dou v x dou v by dou x plus y dou v by dou y plus z dou v by dou z is equal to 0. The question is similar as to this question. So the link is given in the description below. Okay. The next one is u is equal to 2yz by x. See the first question, no module, that is question 2a, is very very important. They may repeat this in the examination. Okay, it's one of the most important questions. Fine. And see, like this, there is one more question, that is if u is equal to f of x minus y, y minus z, z minus x, show that dou v by dou x plus dou v by dou y plus dou v by dou z is equal to 0. That is also very important. Please find the video from my playlist. Okay, they can ask that or this question. The second one is, that is question 2b. If u is equal to 2yz by x, comma v is equal to 3zx by y, w is equal to 4xy by z, then find dou u v w by dou xyz, a very classical question from Jacobians. See, I solved one question like this. U is equal to, there is no 2, 3, 4 and all. It's very simple, plain. U is equal to yz by x, v is equal to zx by y, and w is equal to xy by z. So you please refer that question also. And this question also I have solved here. So the link is given in the description below. Okay. And answer is, I think, 96. Fine. Now question 2c. Apply Maclaurin series to expand cos x into cos y in powers of x and y up to second degree terms. 7 marks question. This I haven't solved, so I'll solve this now. Okay. So the problem here is apply Maclaurin series to expand cos x into cos y in powers of x and y up to second degree terms. See, the Maclaurin series expansion is written as f. See, Maclaurin series is double expansion is about the point 0 comma 0. Okay, while Taylor's is a and b, Maclaurin's is simply 0 and 0. So the expansion, first write the expansion here. Okay, the expansion is given as f of 0 comma 0 plus 1 by 1 factorial. See here, the first term will be here. See, they are asking here in powers of x and y up to only second degree term. 7 marks question. So first f of 0 comma 0, second is x plus y. Means x, wherever x is there, write fx 0 comma 0. What does fx means? Partial derivative with respect to x. That's it. As we write ux, we write dou v by dou x. Fx means dou f by dou x. That is partial differentiation with respect to x. That's all. Okay. See, what I told, first f of 0 comma 0 plus x plus y. I write here for you. So see, since they are asking powers of x and y up to second degree, no? That's why the first will be x plus y and second is x plus y the whole square. Correct. So that is nothing but, see, x plus y means simply x, fx of 0 comma 0 plus again y means y into fy of 0 comma 0. That's it. Plus again see, whole square. Second degree means it will be 1 by 2 factorial. What is x plus y the whole square? X square plus y square plus 2xy. So this is x square. See, x means fx. X square means f double x 0 comma 0 plus x square plus y square. So y square f double y 0 comma 0 plus 2xy. A plus b the whole square is a square plus b square plus 2ab. That is 2xy. See, x square double x, y square double y. xy will be f xy 0 comma 0. That's it. This is the expansion plus so. Okay. That means you have to only find here this term, see, f 0 comma 0, fx, fy 0 comma 0, f double xy, f double x, f double y and fx double y, fxy 0 comma 0. Find the derivatives, put the value 0 comma 0 and enter in the formula. That's all. Okay, so how to go for it this now? See, now first we have the expansion is for cos x cos y. Function is f x comma y equals cos x into cos y. Fine. Now first what we need to find? F 0 comma 0. That means f 0 comma 0 will be cos 0 into cos 0. Wherever there is x, put 0, y 0. What is cos 0? 1. Cos 0, 1. That's all. Fine. Similarly, f x is equal to, now see, f x means you are partially differentiating only the x terms. Cos y, don't touch it as it is. Differentiation of cos x is minus sin x. This will be minus sin x into cos y. That's all. That means f x of 0 comma 0 will be, as you know, sin 0 is always 0. So 0 only. Next, I need to find fy. So fy will be, again see, cos x as it is, don't touch it. Derivative of cos y is minus sin y. Right? Cos y is minus sin y. So fy of 0 comma 0 will be, again, because sin 0 is 0, it is 0. Next, we need to find f double x. So what's f double x? F double x means basically dou square e by dou x square or dou square e by dou square. What we have done, fx, we have found the partial derivative of f with respect to x, the same fx again with respect to x. Okay, if you want I write here, fx what you have found, okay, again with respect to x, that's f double x. Getting it? What is fx here? Again this fx with respect to x, partially differentiate. So that is cos y as it is, fine. Differentiation of fx with respect to x, sin x into cos y. We are differentiating this only with respect to x now. So cos y as it is, again differentiation sin x is cos x and minus as it is. That's it. Therefore, f double x of 0 comma 0 is equal to, because cos 0 is 1, cos 0 is 1, it's 1. Now f double y. So f double y will be equal to, see, we need to partially differentiate fy with respect to y. So again minus cos x as it is, fy is minus cos x into sin y. So again partial differentiate with respect to y. So minus cos x as it is, again differentiation of sin y is what? Cos y. Fine. So now f double y 0 comma 0 is equal to, see, cos 0 1, cos 0 1. This is minus 1. Okay, done. Now the final remaining is fxy. That is fxy will be equal to fx what we have done with respect to what? Y. That means fx is here. So minus sin x as it is with respect to y. Sin x, don't touch it. This fx we are differentiating partially again with respect to y. Sin x minus sin x, don't touch it. Derivative of cos y is again minus sin y. So into minus sin y. So that will be sin x into sin y. Okay, that means fxy will be equal to 0 comma 0 will be, as you know, sin 0 is 0. Sin 0 is 0. That's all. Now we need to expand this now. So expansion, we found all the partial derivatives. Therefore the expansion is given as f of x comma y is equal to, for what we are doing? We are doing for cos x into cos y. So write directly. Therefore that implies cos x into cos y is equal to f 0 comma 0 is 1 plus 1 by 1 factorial x into what is f x is 0 plus y into 0 plus 1 by 2 factorial x square into, we have f double x is 1 plus y square into, what is f double y? Minus 1 plus 2xy into 0. That's all. That means the final result is, implies the solution is cos x into cos of y will be equal to what? See, 1. This whole thing x into 0 plus y into 0 is 0 minus x square by 2 minus y square by 2 because 2 factor is 2, so on. This is the Maclaurin's double expansion for the function cos x into cos y. That's it. Hope it's clear. But first you need to write this compulsory. Okay, if you don't write this expansion, they won't give marks. So that's all. Okay, I hope you understood this question here. That's question number 2C, 7 marks. Now moving on to the model 2, question 3A. If f is equal to x square yz and g is equal to xy minus 3z square, calculate del of bracket del f into del g. This is from the model vector calculus, a problem from divergence of vector or gradient. This question also I solved, the videos here, and the link you can find in the description below. So apart from this, there are other questions also which are solved from divergence. Please refer those in the videos. Those are also very important. Okay. Now, this question number 3b is a vector field is given by f is equal to 6xy plus z cube into I plus 3x square minus z into j plus 3x z square minus y into k. Show that the field is irrotational and hence find its scalar potential. A very, very important question. Okay, so they can ask this question, or I have solved a couple of questions in my, on my channel. You can find the videos in the playlist. Please refer those also. Those are also very, very important. Okay, they can ask this or that question. Now let's solve this question here. I have solved this. So fine. The question is question number 3b. Okay, it says a vector field is given by f vector equals to, it is 6xy plus z cube into I plus 3x square minus z into j, 3x square minus z into j plus 3x z square minus y into k, 3x z square minus y into k. Take the question correctly. So I'll verify it once again. F is equal to 6xy plus z cube into I plus 3x square minus z into j and 3x z square minus y into k. Okay, perfect. Show that the field is irrotational and hence find scalar potential, that is phi. Okay, so this is a very, very important problem, and this problem, these are, as I told you, 2 problems which are solved in my in the videos. You can refer that in a playlist. This is very important. One question will be definitely asked, 100%. Fine. This is for how much? It is for 7 marks. Okay. So the condition for a vector field to be irrotational is, condition is irrotational means del cross f is equal to 0, that is curl is equal to 0. So write down here, irrotational means curl of f equal to 0. That implies del cross f is equal to 0. So del cross of f will be equal to, simple. So what we do? It's a determinant, the curl I, j, k, dou by dou x, dou by dou y, dou by dou z, and the ijk components, that is 6xy plus z cube, then 3x square minus z, and 3xz square minus y. Okay, now this implies, so as you know, how do we solve this determinant? Again, we take this as plus, minus, and plus. So let's solve this now. Pay close attention here. Very important problem. It is I into, see, leave this column, leave the row including I. Okay, this into this. So I write here dou by dou y of 3x z square minus y minus dou by dou z of 3x square minus z bracket closed minus the second term is always minus into j into again when I find for this component j, I will leave this column and leave the row here. So dou by dou x of, be very careful while finding the determinant here, dou by dou x of this 3x z square minus y, 3x z square minus y minus, I will leave this, right? So what remains? Dou by dou z of 6xy plus z cube, 6xy plus z cube. Fine. Lastly, plus k into, I will leave this entire column including the k and this entire row including k. So what remains? Dou by dou x of 3x square minus z minus dou by dou y of 6xy plus z cube, 6xy plus z cube. Done. Okay. So let's evaluate this. If the answer is coming out to be 0, then obviously it is irrotational. Fine. So that is equal to I into dou by dou y means we are partially differentiating only with respect to y. 3x square, there is no y term, 0. Differentiation of minus y is minus 1 minus dou by dou z. See, you are differentiating only the z terms here. 3x square, no z term, 0. Differentiation minus z is minus 1. But here outside the bracket minus sign is there. Minus into minus plus 1. Okay. Minus j into dou by dou x. Here we are differentiating only the x terms. See, x is here. 3x. So 3z square as it is. 3z square will be as it is. Fine. Differentiation of dou by dou x is 1 only. Done. Minus y, no x term, 0. Again minus. See, dou by dou z of 6xy 0 only. There is no z term. But z cube, dou by dou z of z cube, differentiation of z cube is what? 3z square. Okay. Lastly, plus k into dou by dou x of dou by dou x 3x square, differentiation of x square is 2x. 2 3 is 6. So this will be 6x minus again dou by dou y of 6xy, y is there. Z cube no y term, so leave it 0. Differentiation of 6xy, 6x as it is with respect to y, differentiation of y is 1. That's it. Now if you see here, cancels 3z square minus 3z square, cancels is equal to what? 0. That's it. Therefore, del we can write here. Okay, better write it because the problem is asked for 7 mass. So please write it as I am writing it. Del cross f is equal to 0. That means it is what? F is irrotational. Okay, up till here we'll carry. Up till here we'll carry at least 3 to 4 marks. Fine. Now let's move on to the second part and hence find the scalar potential. See, the scalar potential means what? It is phi. Okay. Now, as if you see my previous videos or refer the playlist, I solved such questions. I mentioned in the theory also that to find the phi, we use a standard formula. The formula is what? Del phi is equal to f. A standard one. You have to use this. Okay. Del phi is equal to what? F. So if you use this, what is del phi? Del meaning is the inverse del operator. The meaning of del is dou by dou x of I plus dou by dou y of j plus dou by dou z of k, as you people already know. So del phi means, that implies dou phi by dou x of I plus dou phi by dou y of j plus dou phi by dou z of k equals to, what is the factor? They give in the question 6xy plus z cube into I. 6xy plus 3x square minus j plus 3xz square minus y into k. Okay. So this is what we have. Let's compare. So what to compare here? See, we compare here, no, we can compare the item, j, and k. Okay, so if you compare the I and I is here, I is here. If you compare both, so what do you get here? We get, implies dou phi by dou x is equal to what? 6xy plus z cube. Fine. Therefore, phi will be equal to, see, when I find phi, I remove del from the left, so what remains right side? Integration. So it will be integration of 6xy plus z cube. See, I am integrating here dou x, no, with respect to x. So dx, and one more thing you have to mention here, that is very important. Since you are integrating with respect to x, partial integration, the constants are, see, x, y, z. Since you are integrating with respect to x, what remains? Y and z. So to write plus f of y comma z, compulsory. Okay. So to do the integration, so phi is equal to 6 into, so what is the, 6 into, here we are integrating only the x terms here. So 6 into integration x is what? X square by 2 into y as it is, plus again z cube as it is. Here again I repeat this, integration of 1 dx is x, because differentiation of x is 1, so integration of 1 dx is x. So integration of 1 exists here, be careful. Z cube is there, it's not 0 and all. Okay, z cube will be as it is. In z cube into we take it as 1 dx. So z cube as it is, integration of 1 is what? X plus f of y comma z. So phi here will be 3x square y plus x z cube plus f of y comma z. Okay, we have phi. Similarly, dou phi by, what's the next case? We have dou phi by dou y. So here what we do, we compare the, j and j terms. Okay, so if we compare the j and j terms, what do we get here? We get here dou phi by dou y is equal to dou phi by dou y equals, what are the y terms here? 3x square minus z. So 3x square minus z. So phi will be integration of 3x square minus z dy, since integrating to y. So again this will be phi is equal to 3x square as it is. As I told you, 1 dy, 1 will be there. Integration of 1 dy is y into y. If there is a y term with respect to y, you integrate y square by 2, y square by 2 by 3, so on. But 3x square as it is, into 1 will be there, into integration of 1 dy is y, minus z as it is, integration of again 1 is y, plus x, y, z. Since you are integrating here with respect to y, remaining is x and z. So f of x comma z. That means here phi will be equal to, okay, this as it is, that is 3x square y minus zy. Fine, no cancellation. Lastly, dou phi by dou z is equal to 3x square minus y. So phi is equal to integration of 3x square minus y dz. Now we integrate this. So phi will be 3x as it is, integration that is what? Z cube by 3 minus y as it is into z, plus, correct now? So y as it is, integration 1 dz is z, and plus, since I am integrating with respect to z here, constants are f x y z, remaining is x y. So we have f of x y. Okay, 3 cancels. So phi is x z cube minus y z plus f of x comma y. Therefore, the scalar potential, so I have all these values here. We have 3x square y plus x z cube plus f of x y. Phi is equal to 3x square y minus zy plus f of x comma z. And lastly, phi is equal to x z cube minus y z plus f of x y. So what we do to find the scalar potential phi, that implies to find the scalar potential phi, okay, is equal to, so what we do is scalar potential phi, what we do is, see, we add all the terms. So while adding, when the term is repeating more than once, take it only once. Are you getting my point? If it's repeating more than once, take it only once, because function plus function become function. X plus x will become x only. Okay, so here I have 3x square y plus x z cube. I write here 3x square y plus x z cube Fine. Again, next see 3x square y is repeating. So don't take it. Take it only once. 3x square y repeating. Take it only once. So plus xz cube as it is. See minus zy. Minus zy. Again here xz cube. See again repeating. Xz cube minus zy or yz repeating. So that's all. So if it is repeating, take it only once. That's all. So this is my scalar potential. That's it. So a very interesting problem. This may be asked in examination, and I have been asked around 3 to 4 times in the semester exams. So we showed here that the field is irrotational by proving del cross f is 0, and from the basic idea of del phi is equal to f, we found a scalar potential as phi is equal to 3x square y plus xz cube minus zy. Only remember, don't take repeated term, take it only once. That's all. This is how it is done. Okay. Okay, so module 2 question 3b over the vector irrotational and finding the scalar potential, very important question. So again, please do refer the playlist for more videos like this, because this is compulsory question. They will 100% ask this in first 7 marks. Okay. The next one is, and also please again do refer the Facebook page and Instagram page for more important questions on vector calculus. Okay. Next is question number 3c. Express the vector f is equal to xi plus 2yj plus yz into k in spherical polar coordinates. The same questions may repeat. They might not change the values also. So that this problem I also solved. You can refer it and find a video link in the playlist. Fine. The next problem is, that is question number 4a. That is find the directional derivative of f of the second. So it says find the directional derivative of f x y z is equal to 4 e raised to 2x minus y plus z at the point 1 1 minus 1 in the direction towards the point minus 3 5 6. So one more very important problem from the direction derivatives, and as I told you, there are much more questions from the direction derivatives, which is also a compulsory concept which may be asked in examination. I solved some 3 to 4 questions, so please refer them also, and those all questions are discussed in my Facebook and Instagram page in the most likely question to be asked or important questions. So let's solve this here now. I now solve this question. Question number 4a. Question number 4a says find the directional derivative. Find the directional derivative of f of xyz of f of xyz equals, it's 4 e raised to 2x minus y plus z. 4 e raised to 2x minus y plus z at the point 1 comma minus 1 in the direction towards the point minus 3 5 6. Okay, so this is the problem we need to solve here. Fine. So let's solve this. So find the directional derivative of the function f x y z is equal to 4 e raised to 2x minus y plus z at the point in the direction towards the point. So first, the basic of directional derivative is given as a directional derivative of del phi in direction d vector is given as directional derivative is equal to del phi into that given direction upon modulus of the given direction. Fine. Now here the surface is given as f. So we have taken del phi. So here you need to take del f. So we have f of x y z equals 4 e raised to 2x minus y plus z. Fine. Therefore del f is equal to, see, the meaning of del, as you know, is dou by dou x of I plus dou by dou I of j plus dou by dou z of k. Fine. That means this will be dou by dou x of I plus dou by dou I of j plus dou by dou z of k into f. This will be now, if I take f inside, this will be dou f by dou x of I plus dou f dou y of j plus dou f by dou z of k, where dou f by dou x, dou y by dou y and dou f by dou z are the partial derivatives of f with respect to x, y and z. Here the function, that is the what we call it as the surface f, is partially differentiated with respect to x, y and z and I, j, k applied to it. That's why I do the del f, okay, the gradient. Now let's solve this. So this means now del f equals to, see, I'll do each step systematically, step by step, so understand it here. So what is f given? So I write dou by dou x of I into what is alright, okay, dou by dou x of f, right? What is f? 4e raised to 2x minus y plus z into I plus dou by dou y of, again say 4e raised to 2x minus y plus z into k plus lastly dou by dou z of 4e raised to 2x minus y plus z into this is second term is j and this one is k. Fine. So the f vector, the surface f is partially differentiated with x, y and z. So let's do it now. So it implies del f equals, so what's that? See, dou by dou x means we are partially differentiating with respect to x, 4 as it is. Now differentiation of e raised to x is e raised to x only, but here it is e raised to 2x minus y plus z will be e raised to 2x minus y plus z as it is, but again it becomes a chain rule. Again, since we are partially differentiating only with respect to x, that's why again differentiation of e raised to 2x minus y plus z as it is, again differentiation of 2x minus y plus z is respect to x, y and z is 0, no x term, differentiation of 2x will be into 2 into I plus. Now similarly dou by dou y means we are partially differentiating, listen carefully here, we are partially differentiating only with respect to y. So as differentiation of e raised to x is e raised to x only, the chain rule, it will be e raised to 4 into e raised to 2x minus y plus z will be as it is, but again chain rule, differentiation of 2x minus y plus z with respect to y, 2x is 0, z is 0, because we are partially differentiating with respect to y, so y is there, so differentiation of minus y is what? Into minus 1 into j plus lastly dou by dou z of, see here with respect to z, so this will be again 4e raised to 2x minus y plus z as it is, again see 2x minus y 0, differentiation z is 1 into k, that's it. So we found del f. Now at the point, at point 1 1 minus 1, that means del f at the point 1 1 minus 1, the meaning of this is nothing but see 1 1 minus 1, right? Okay, 1 1 minus 1 means in place of x you need to put 1, y 1 and z minus 1, that's it. That's a simple meaning. So whenever you at the point, so find the gradient del f and in place of x, y and z put 1 1 and minus 1, okay. So let's do that. So this will be now 4, see, if in place of x we put 1 2, this will become 2, I write it, 2 minus 1 plus 1 into 2 into I, then plus again see all the terms will be having the same value, again in place of x put 2, it will be e raised to 2 and the 2 minus y is 1 and z is minus 1 into minus 1 into j, and lastly 4 e raised to 2 minus 1 into k. So that will be now del f at the point 1 1 minus 1 is equal to, so this will be 4 to the 8, so now okay, 4 into e raised to, right? Okay, this is 4 into e raised to, fine, sorry, so it will be 4 to the 8i, why? Because the e raised to 2 minus 1 1, okay, this is 2 minus of minus 1. So 2 minus 2 is 0. Here also 2 minus 2 0, 2 minus 2 0. And what is e raised to 0? E raised to 0 is 1. That's it. So all these terms e raised to 2 minus 1 become e raised to 0, that is 1. So 8i minus, this will be 4 into minus 1, minus 4j and plus 4k. This is what you get for del f at the point 8i minus 4j plus 4k. Okay, so we found del f. Now since directional derivative del f del phi into d vector by modulus of d vector, so we found in place of del phi, we found del f. But we need to know d vector direction. What direction given? See, a very important point here. Direction is from P to Q I take. Okay, so what I'll take? Let's take this as P. That is, I'll take like this. From P, let's say from P. What is P? 1, 1, minus 1. 2 I'll take say Q. What is Q? Let's take minus 3, 5, 6. Because see this, you know, read the question carefully. In the direction towards the point, minus 3, 5, 6, very, very important. Don't take directly minus 3i plus 5j plus 6k. I have seen students doing that. See, direction is from P to Q. Means, what is that? PQ. Direction from P to Q. Between 2 points, P2. And how do you write it? Simple basics. Simply don't do nothing. It will be minus 3 minus 1, minus 3 minus 1, comma, 5 minus 1, comma, 6 minus of minus plus 1. That's it. Am I right? So this will be now. So what I did is simply nothing. See, minus 3, this PQ means this point minus this point. So what is this point? Minus 3 minus this 1. 5 minus 1. Then 6 minus of minus 1. This minus this. That is the basics what I learned in your 12th standard. Okay. Distance with 2 points. Now I have this as minus 4, 4 and 7. Now therefore the direction D vector is nothing but, see, minus 4, 4, 7, as you know it's written as xi plus yj plus zk, any direction. So I can write this as is minus 4i plus 4j plus 7k. That's it. Therefore the directional derivative of del f in direction, we got it as minus 4i plus 4j plus 7k is nothing but, what's that? We have del f as 8i minus 4j plus 4k, 8i minus 4j plus 4k into the given direction. What's that? Minus 4i plus 4j plus 7k whole divided by modulus of this. Modulus of d. What is the modulus of this direction? Modulus means root of the square of all the components positive. That is root of, see, minus, that is always take positive, okay? What is plus or minus? Always take positive. 4 square is 16 plus 16 plus 7 square 49. Okay, so this will be now, see, this will be, see, 8 into minus 4. See, when we multiply both I, J, K, I will go to I, J will go to J, and K will go to K. Rest all is 0. Simply wherever I is there, we will go to I. Because I into I is 1, J into J is 1, K into K is 1. Okay, remember that. So simple multiplication, I into I 1, 8 4 is 32. So this will be minus 32. Be careful of our signs. Minus 4 into plus 4. Minus 16, J into J is 1. As you know, lastly 4 7 is 28. Divide by root of, what's this? 16 plus 16, 32. 32 plus 49 is 81. That's it. Okay, so that is nothing but equal to, this equals to, so let's see what becomes. So minus 32 minus 16 is, okay, what's this now? Minus 32 minus 16 is minus 48. Minus 48 plus 20 will be, yeah, it's plus 20. That's it. Correct now? So minus 48 plus 20 will be 20. So 20 by 9. That's it. Thinks is the correct answer. Therefore, directional derivative of, so therefore that implies directional derivative of del f along the direction minus 4i plus 4j plus 7k is how much? 20/9. That's it. That's the answer. Okay. That's it. I hope you understood how to get the solution here to find a direction derivative. Okay. This question is something different. While as the question which I solved in my previous, you can see the videos, they are also very, very important. They are also totally different. So please do those videos. Might be they can ask this or those questions in the examination. Okay, fine. Okay, as we are done with this problem, the next is 4b. Find divergence and curl f where f is equal to grad x cube plus y cube plus z cube minus 3x. Very, 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 very important problem. They may repeat this in the examination. Be careful. And this problem, since it's very important, I have solved, and the link you can find in the description below. Please go refer it. Don't miss it. Okay. And the next one is the 4c. Express the vector f is equal to 2xy plus 3yj minus zk in cylindrical polar coordinates. As I told you, in module 2 there will be option express as spherical polar or cylindrical polar, and both these questions are important. One may repeat. One, obviously both are going to repeat. So this also I have solved in a very simple way. So it is express the vector f is equal to 2xy plus 3yj minus zk in cylindrical polar. It's a simple than spherical polar. So please do refer the link in the playlist and solve it. Okay. Now the next one is module 3, a very, very important and interesting module. Again, one thing I will tell you, see, listen to me very carefully. See, since matrices, the linear algebra is very easy module. So students, they try to attempt it first. So my advice is don't do that. Please start from the first module. Okay, first then second, then you can go third, but please start from the first module. I don't want to give the reasons for that. Do it. It will be very, very beneficial for you. Okay. Now, the module 3 is linear algebra. So the first problem is find the constant b, the rank of so and so is 1, 1, minus 1, 0, 4, 4, minus 3, 1, b, 2, 2, 2, 9, 9, b, 3 is 3. Okay, and I have already solved this problem. The problem is here. The link is given in description, and I think the value is b is minus 6. Okay. Apart from this, I suggest you to solve the other questions on rank. Okay, there are 2-3 questions very important. Please check to the playlist. Fine. And also the Facebook page for more problems on rank of the matrix. And this module is very, very important, and this is totally scoring module. So don't miss this module. Try to solve each and every question from the playlist and the questions on the problem which I mentioned in the Instagram and Facebook page as important questions. Please do that. Be careful. The next question is find a model matrix of 4, 1, 2, 3 and verify diagonal relation. One more very important problem, and this problem also solved in a very easy way. So please do refer the link in the playlist. And also one more very important thing, please sorry to interrupt here in between. See, I shared my WhatsApp number and email ID in the description. If possible, please send your question papers after the examination, as it will help the other students in the future. Also do share in the comments how you examined and your experience. Okay. So now moving back to this question here. See, next question is question 5b. I told you the link is given in description below. Diagonal relation. As for VTU, you have only diagonal relation of only 2x2 matrix. So this problem is very important. Okay. Also the next question C, very important problem. I shared the video recently. That is traffic flow problem. They may discuss the same problem as it is. So please, you can get full 7 marks. This problem also I solved in the most easiest way as possible. Okay, so that even if the lowest basic you can understand this problem. So link is given in description below. Please do refer that and practice it. See, as I told, practice is the main key. See, I have done my part of providing guidance and solutions. Now it's your responsibility to practice regularly, revise the videos and stay focused. Fine. Now the next one is question number 5a. This is a very, very important and most frequently asked question in linear algebra relating to consistency of the system of equation. The problem is question number 6a. Investigate the values of lambda and mu so that the equations 2x plus 3y plus 5z is equal to 9, 3x plus 7x plus 5y, 7x plus 3y minus 2z. Excuse me, I read the question here. Okay. 7x plus 3y minus 2z is equal to 8 and 2x plus 3y plus lambda z is equal to mu have no solution, unique solution and infinite number of solution. A question carrying 6 marks, compulsory question. They may repeat this question for sure. Please don't miss the question. Okay, and since it is very important, I have solved this question already. Please do refer the link. Whatever I am telling you, you will find with the question number like 6A, 6B and all, you will find all the links given in the description. Please do refer that. Okay, I made everything easy for you. And as I always keep on telling you, see, practice and practice is the main key for scoring in mathematics. So don't target on getting passing marks or merely 50-60 marks. As my student, I want you to get more than 80-90% marks. So what I mean to tell you, see, even 1 week of sincere practice is enough to score more than 80-90% of marks if you use your time properly. Okay, so please practice these questions. And why I am stressing, because matrices, linear algebra is very important, and this is the gateway to score the full marks in this module. Okay, now the question C is determine the eigenvalues and the corresponding eigenvectors for the matrix 8 minus 6 2 minus 6 7 minus 4 and 2 minus 4 3. 7 marks question. Fine. And this is the theoretical question. This problem also is very important, and I have explained this question number 6C in a very beautiful, systematic and very easy way in the given video. This link also will find in the description below. And along with this, there are some couple of problems which I have mentioned in the Facebook and Instagram page as important question. Please work that also and go. Okay, fine. Now moving on to module 4. I think I have missed one question here. Question number 6B. Sorry for that. I went directly to question number C. Okay, the question number 6B is apply Gauss-Jordan method to approximate the solutions of the system. See, I think the question is misprinted here. The question is not Gauss-Jordan, it's Gauss-Seidel method, because they are given the initial solution 0 0 0 and they are asking to perform 4 iteration. So simple misprint is it's not apply Gauss-Jordan, it's Gauss-Seidel method, and this I have not solved. So let's solve this problem here now. So the problem here, question number 6B is, as I told you, it's apply Gauss-Seidel method, not Jordan. Okay, misprint. You can rectify that. Apply Gauss-Seidel method to approximate the solution of a system. I write the system here. It is given as okay, it is question number 6B, right? Question number 6B. Fine. So the apply Gauss-Seidel method to approximate the solutions of the system. It is given 83x plus 11y minus 4z equals 95. Then 7x plus 52y plus 13z equals 104, and finally 3x plus 8y plus 29z equals 71. And the initial solution is, initial value is given as 0 0 0. That means in as we are doing this Gauss-Seidel method, this is what Gauss-Seidel method. So in Gauss-Seidel method, the initial value is 0 0 0 means x is equal to 0, y is equal to 0 and z is equal to 0. Okay, so let's solve this using the Gauss-Seidel method. And the Gauss-Seidel iterative method, see I write here Gauss-Seidel method. Okay. See the Gauss-Seidel method, to solve the problem using Gauss-Seidel method. So the problem here is 8x plus, see one more time, while taking the problem from the question paper to the answer sheet, be careful, verify twice. If numeric value or the sign goes wrong, then everything goes to waste. Fine. So it's Gauss-Seidel method, that is 83x plus 11y minus 4z is equal to 95 and 7x plus 52y plus 13z is equal to 104. 3x plus 8y plus 29z is equal to 71, right? Okay, fine. So everything is correct. And initial value is given as 0 0 0. So x is 0, y is 0, z is 0. So the Gauss-Seidel method is very simple. So first, the basic idea, the basic condition for applying the Gauss-Seidel method is what? This element 83 should be greater than sum of this and this. 83 is greater than 11 minus 4. Perfect. The second, along the diagonal, see, 52 should be greater than 7 plus 13. Obviously, 52 is greater than 20. And lastly, 29 greater than 8 plus 3, 11. Okay, so this is a condition required. If the condition is not satisfied, then simply change the rows. Shift this here, shift the first, first row second to second first, and so that this condition is satisfied. All element along the principal diagonal should be greater than the other elements. Understood now? 83 greater than 11 minus 4. Perfect. 52 greater than 7 plus 13. Suppose this 3x plus 8y plus 29z was here, second row. So alright, this is equation 1, 2 and 3. So suppose if this was second, then obviously 8 is not greater than 3 plus 29. 8 is lesser than 32. So what you do? The third row replace to second and second to third. That's all. So this condition should be met. Otherwise, strictly you cannot apply the Gauss-Seidel method. Be careful about it. Directly you cannot apply. The condition should be satisfied. Okay. Now once the condition is satisfied, you make an equation. How? See, first 83x plus 11y minus 4z is equal to 95. So x will be equal to, tell me what? See, 83x is this much. So x will be equal to, it's a simple equation. Take all terms this side. So this will be 95 minus 11y plus 4z divided by 1 by 83. That's it. Correct? Okay. 1 divided by 83 into this whole thing. 1 by 83. X is what? Simple mathematical basics. 1 by 83. 95 minus 11 by minus go that side to become plus. Similarly, y. See this diagram. Y is equal to 1 by 52. 1 divided by 52 into, take all terms this side, 104 minus 7x minus 13z. That's it. And lastly, this z. Z is equal to, what is that? 29z is equal to this much. So z is equal to 1 by 29, 71 minus 3x minus, this is 8y, right? Okay, 8y. That's it. Fine. So these are all the equations which we have. Fine. Now these equations, for this equation you have to make, they have mentioned 4 iterations, you have to do 4 iterations. These are the important equations which we will be using to solve. Okay. So how the Gauss-Seidel method works? So as they mentioned 4 iterations, we will do that. So let's say the first iteration. So what is the initial value? X is equal to 0, y is equal to 0, z is equal to 0. Fine. It means first iteration x is equal to 1 by 85, 95 minus, what is y? See, 11y plus z. What is y? 0, 0. So I will use the calculator here to solve this. Better practice along with me, so that if you now while watching the video and practicing with me, I think this is more than enough. Okay, one more time you practice, it will be perfectly stored here perfectly. Fine. Now let's clear the memory here. The best practice, always do when you are using a calculator, always after every problem clear the memory, because in this calculators the results will be stored in the register. So sometimes the results overlap and you may get wrong answers and you cannot take any risk here. So please clear the memories. 3. Okay. All. Now x is equal to 95 by 85. So 95 divided by 85 is equal to, yes, it is right decimals, and minimum 5 decimal places required. Don't approximate to 2-3 decimal. See, the answer is coming as 1.1176. Don't write 1.12 and all. You lose the marks. Minimum 4 to 5 decimal places compulsory required. So this is 1.11764. Similarly, y is equal to 1 by 52, 104 minus, now see the magic here, minus 7x. The new value of x will be here, 7 into, what is the new value of x? The value that you found will become the new value for the next iterations. Okay, it is minus 7 into 1.11764 minus 13 into z is 0 only, so put 0. Now solve this. So this will be now 104. So as this stored in answer, so I'll use that to make things faster. Minus bracket 7 into answer is equal to, divided by 52 is equal to, and it comes 1.8495. 1.84954. I'll take this 84954. Similarly, last value y is equal, z is equal to, sorry, 1 by 29. It's 71 minus 3 into, what's new value of x? 1.11764, and minus 8 into new value of y is 1.84954, which is stored in the answer. Okay. So let's solve this now. 71 minus bracket 3 into, put the brackets, 1.11764 bracket closed, minus bracket 8 into answer equals, divided by 29 equal to 1.82244. This is 1.82244. 1.82284. Yeah, that's all. Now next iteration, second iteration will be, again we'll write x is equal to, say same 1 by 83 into, say 95 minus 11y, 95 minus 11 into y. So 11 into, what is new y? From 0 it became, new y is 1.84954. 1.84954. Correct. 11 plus 4z plus 4 into, what's that? Z is 1.82244. 1.82244, which is stored in the answer. So this will be now 95 minus bracket 11 into 1.84954 bracket closed, plus bracket 4 into answer equals to, divided by 83 equals to, I am getting 0.98728. 0.98728. Fine. The new y is equal to, now next y, 1 by 52, 1 by 52, 104 minus 7 into, what is new x? 0.98728. I hope you are getting this clear now. So whatever value you are getting now, that becomes a new value for the next step, next variable. Okay. So y is equal to minus 7 into, and minus 13z. So minus 13 into, what is new z? 1.82244. 1.82244. So that will be now, so this is stored here in the answer. So I'll write 104 minus bracket 7 into answer minus 13 into 1.82244 is equal to, divided by 52 is equal to, so this is 1.41149. Okay. Lastly, z is equal to 1 by 29. So it's 71 minus, what is new x? It's 0.98728. Is that right? Yeah. Minus 8y. Minus 8 into, what is new y? 1.41149. Okay. So that will be equal to now 71 minus 3 into 0.98728 minus its bracket 8 into 1.41149 bracket closed is equal to, divided by 29 is equal to 1.95, 1.95676. Okay. So the third iteration will be, again x is equal to, what's that? 1 by 83, 95 minus 11y, 95 minus 11 into, what is y? 1.41149. Okay. x 1 by 83 plus 4z. So plus what is new z? 1.95676. So that will be 95 minus bracket 11 into 1.4 1149 bracket closed plus bracket 4 into its answer, right, is equal to divided by 83 is equal to, we get 1.05. Next y is equal to, similarly it's 1 by 52, 104 minus 7x. So 7 into what is new x now? 1.05181 minus 13z. Minus 13 into new z is, I found here, 1.95676. That will be, so 104 minus bracket 7 into that answer minus bracket 13 into 1.95676 is equal to, divided by 52 is equal to 1.3692. 1.36921. So please verify this with your calculators. So lastly, z is equal to 1 by 29. 71 minus 3 into, what is new x? 1.05181 minus 8y. Minus 8 into, what is new y? 1.36921. Okay. That will be now 71 minus bracket 3 into 1.05181 minus bracket 8 into 1.36921 equals, divided by 29 equals 1.96175. 1.96175. Okay. Now we'll do the last iteration, that is fourth iteration will be, fourth iteration is, again x is equal to same process. See, 1 by 83, 95 minus 11 into, what is new y? It's 1.36921 plus 4z plus 4, what is new z? 1.96175. So that will be 95 minus bracket 11 into 1.36921 bracket closed plus bracket 4 into answer equals to, divided by 83 equals to, it's coming as 1.057 1.05766. Similarly, y will be equal to now 1 by 52, 104 minus 7x, 104 minus 7 into x is 1.05766 and minus 13z, minus 13 into, what is z? Z is 1.96175. Okay. So that will be now 104 minus 7 into 1.05766 close minus bracket 13 into 1.96175 equals to, divided by 52 equals to 1.367185. Lastly, z is equal to, it's 1 by 21, 1 by 29, 1 by 29, 71 minus 3x, 71 minus 3 into, what is new x? It's 1.05766 and minus 8y. What's the new y? 8y, 8 into 1.367185, that is stored in answer here in the calculator. So we have this as 71 minus 3 into 1.05766 bracket minus bracket 8 into answer is equal to divided by 29 is equal to 1.9617. 1.961708. Now if you see here, I think 4 iterations are enough here. Okay, so what I can see, you can see here, you see the last 4 iterations, right? Here, see the values, third and fourth iteration, the values are approximately same. Getting, see 1.0581, 1.05, 1.36, 1.36, so 1.96, 1.75, 1.96, so they are approximately same. So they both match each other, so stop there only. So minimum, since the question is asked for on 7 marks, minimum 4 iteration is compulsory required. Okay, again see the best thing, see in the problem here they have mentioned that clearly that where it is, yeah, perform 4 iterations. You have to perform 7 marks. Sometimes they won't mention, so 4 is compulsory required. Other simplest technique of how to check how much required is what I show you here. Take a calculator, okay, and find the values here. Where if the values match the values in a calculator, stop. That's it. So we'll see that. So first mode equation. First, okay, shift clear the memory here in 3 AC. Now see we have mode. Let's go to equation 5, and here it is what A, B, C, D. So it is number second A, B, C, D, N. Okay, so let's put all the values here. 8, 11 minus 80, sorry, 83 is equal to 11 is equal to minus 4 equals to 95 equals to 7 equals to 52 equals to 13 equals to 104 equals to 3 equals to 8 equals to 29 equals to 71 equals to, we are getting the value of x as 347 by ST. See, perfect answer, 1.05792. So approximately same. Stop it there only. So even if 3 places after decimal is same, stop it. Is equal to, second value is 1.367165. 1.367165 is 8565. Perfect. Then third value y is 1.961686. 1.9616. It is 1.9617 is approximately same. So stop it there only, and that's the answer. Full 7 marks. This is the verify is in calculator if your answer is correct or wrong. Okay. Some people if the answer is even wrong, they try to use a calculator and write the answer and manipulate there. Then sometimes they get full marks also. Okay, that depends on examiner. Fine. So we are done with this. What is that? Question number 6B, and question number C, as I told, is already there. We discussed this already. Okay. So now next is module 4, the new module, that is vector spaces. Module 4, question 7A, verify whether V is equal to 1 minus 2 phi in R cube is linear combination of vectors. U1 is equal to 1 triple 1. U2 1 2 3 and U3 is equal to 2 minus 1 1. This all questions from the module 4 and 5 solved. So the solution is here and the link is given in description. Please go through that. Okay. Question number 7B, determine whether W is equal to bracket ABC such that A plus B plus C is equal to 0 is a subspace of R cube or not. 7 marks question, very simple question, simple solution. This question is also solved, and the link you can find respective for all solution. The link is given in description. Please go refer that. And see, very important question. They may guarantee ask this question in the examination. Prepare and go. Find this question number 7C. Find the basis and dimension of row space, column space, and null space of the matrix. Very important problem. This also is solved in a very easy way. So please do refer the video. The link is given in description and make yourself perfect. Okay. See, again I am telling you, I want you to score more than 80 to 90% marks, and you can do that. 1 week is more than enough. I am telling you to score more than 80-90% because you have the correct resources with you. Okay. So you can definitely do that. Okay, but utilize the time properly. Fine. Next you have module 4 here. Question 8, second part. Question 8 is find the basis and dimension of the subspace. Very important question. Again, as I told you, from module 4 and module 5 all questions have been solved. So question number 8A, the solution you can see here. The link is given. Please refer that. Question number B is also interesting question, inner products. They can ask the same question. Also the question is solved. Please refer the link below. Also please, for question number 8c, find the coordinates of the vector 1, minus 3, 2 with respect to the basis. 111, 110, 100 is also solved. Okay, so please find the link in the description below and practice it. And lastly, module 5. Before going to module 5, once again I want to remind you, after you get your question papers, please WhatsApp me or email me. The link is my WhatsApp number is given in description. That will be very, very useful for me, for the future students, because I am going to meet you in the second semester, okay, with the engineering mathematics 2. But papers which you send to me will be helpful for the further students who will be joining engineering. Okay. Now the module 5, question 9a. Verify whether the transformation is defined by txy 3x plus 4y 10x minus 4y plus 3 linear or not. Very, very important question, compulsory question. Please practice that. The videos, the solution is already there and the link in the description. Please refer that. That is question number 9a. Then question number 9b. Prove that the transformation f from R square to R square singular and find its kernel. That is also solved. Okay. I solved this problem in the most easiest way possible so that you can understand. Question number 9b, the solution for the link is given in description. Please refer that. And question number 9c, find the rank and nullity. Very, very important question. They have to give this question. Okay, very, very important question from linear transformation. They will compulsory give this question. Please don't miss it. I solved the problem. So I also request you to please solve the other questions also regarding this. So this question is important. They may repeat the same question because this question, that is find a rank and nullity. This has been repeated around 1 to 2 or twice in the previous papers for the older schemes. So please do that. Question number 9c, the solution is given in the link is given in description. Please refer. Then R, the last part, question number 10a. Check whether the transformation defined by x square x cube is linear or not. Simple question, only for 6 marks. I have already solved this question. So please check the solution. The link is given in description. Question number 10a. Also question number 10b. You'll find the solution is you already solved the solution. You'll find the link in description. And the last question number 10c is let f be linear transformation defined in vector space R square through f of xy is equal to 2x plus y, 3x plus 2y, show that f is invertible and hence find f inverse. The last problem, I solved it. The solution is in front of you. You can find the link in the description below. So I have totally solved a model question paper here, which is very important. As I told you, please practice the model question paper along with the my videos on the playlist and along with the most important questions which are given in my Facebook and Instagram page. That is enough for you to score more than 80 to 90% of marks. Okay. So as I told you, I am going through critical health conditions. So despite that, I know that this time is crucial for you. So I tried my best. Despite pain, I tried my best to bring up this solution to model question paper. So I had done my part. I gave the guidance and all the solutions. Now it's your turn. Okay. So it's your responsibility to practice regularly, practice more, practice the videos, practice other question papers and stay focused. As I told you, 1 week is enough for you if you use this model question paper other solution. Practice it, okay? And if you practice 1 week perfectly, you are going to get easily more than 80 to 90% of marks. But use your time wisely, don't waste your time. So that's all for today's video. I will see you in the next semester. Please do favor to me by uploading, by sharing the question papers of whatever, this 1BMATS101, and if other students are referring it for the other branches, you also please, I'll try to upload the solutions soon as my help permits. So you also please try to share your papers with me on my WhatsApp number or email ID. So that's all for today. Best of luck for your exams. Stay confident, stay focused, practice well and keep revising. Happy engineering. I will see you in the next semester, second semester. So I hope you to see a success in the results. So please do post a comment about the results. So see you in the next semester. Thank you. Best of luck once again. Bye.